Welcome friends, in this one we're going to take a look at limits at infinity using numerical and graphical evidence. So in this case x, your independent variable, is going to go towards positive infinity or towards negative infinity. So we're going to begin with one of the most elementary functions, f of x equals 1 over x. Let's understand this thing a little better. So what happens when x goes towards positive infinity? You might want to plug in a value like, for example, 10. So that would be 1 over 10, which is then just an output of... So notice that when x is 10, the output is 0.1. When 100 goes in, we have f of 100. Next, that would be 1 over 100, which is 0.01. You can probably already see a pattern in the outputs, which is that they're getting smaller and smaller. F of 1000, when that goes in, you have 1 divided by 1000, which is then 0.001. So as x increases, we can tell that the outputs are getting smaller and smaller and smaller. This pattern suggests that the following is true. The limit as x goes to positive infinity of 1 over x is just equal here to basically 0. What happens in the following case? When x goes towards negative infinity. So then you would do, for example, f of negative 10 first. Negative 10 for x. Then you would have here 1 over negative 10. That's negative 0.1. F of negative 100. X is sliding towards negative infinity, remember. That would be 1 over negative 100, which would be then negative 0.01. F of negative 1000, moving towards negative infinity on x. This would be here then 1 over negative 1000, which would be negative 0.001. As you can see, these values, while they're negative, they're still an absolute value, at least, getting closer and closer and closer to 0. So this suggests that the limit, as x approaches negative infinity, of our f of x is equal to 0 also. So make a graph. And when you look at graphs and then limits at infinity, you have to look at graphs the correct way, so to speak, so that you see the right patterns emerge. So graph 1 over x. If you graph this and then look only around x equals 0, like here, for example, where x is 1 and 2, or x is negative 1, this is not what we need. Because we want to see what happens when x goes towards positive or negative infinity. You want to grab x's that are big. So for example, right now the upper limit on x on the right side is about 3.2. I'm going to make that say 1000. And it changes the picture quite dramatically. What this shows you immediately then is the following. That as x increases towards positive infinity, 200, 400, 600, 800, the values of the function get smaller. They approach 0, in other words. And you cannot really separate the function from the x-axis anymore. On the left side, same principle. Look carefully. When x goes towards negative infinity, negative 200, negative 400, negative 600, negative 800, the values of the function also go towards 0. And you can't really separate the function from the x-axis anymore. Be careful though, you see, because if you zoom in more like this, then things perhaps become a bit more separate. So when you're graphing limits, and then you're looking at what happens at infinity, you want to keep all of this in mind. Having said that, remember you are focusing essentially on what happens right here, see? Let's look at this example next. The limit as x goes to positive infinity, say, of 1 over x squared plus x. If I graph this, you want to make sure you graph it the right way so it's instructive. So 1 over x squared plus x is what you're graphing. At first it looks like this, and then you kind of scrunch over it this way to show bigger values of x. And you see this graph actually looks pretty much like the previous graph in terms of the behavior of the function at positive infinity. In other words, it's 0 in the limit. You're looking at what happens to the y-coordinates out here. Those y-coordinates are getting smaller and smaller towards 0. So in other words, you would answer the question by saying that the limit as x approaches positive infinity of 1 over x squared plus x is 0. Let's look at another example so we don't think that the limit is always equal to 0. Let's look at this one next. So the limit as x approaches, say, positive infinity of something like the following. Say 2x squared, and we divide this by 4x squared, say, plus 3x, and then plus 2. What is it in this case? Well, let's graph it. We're going to have the following. 2x squared, the numerator, and then the bottom 4x squared, and then plus 3x, and then plus 2. Now this behavior is different. Notice that this time, you can tell that the graph bounces off at 0 and then kind of goes towards a value this way. What is that value? Since we're doing this just as an introduction using graphs, I'm going to scrunch over this way and I'm going to pull up this way so we can study the behavior a bit more carefully. We need some numerical evidence for what's happening. And what you see here, let me do it a bit more, is that the following is true. the values of the function seem to approach 1/2 from below. Let me illustrate this with an arrow so we're clear on what's happening. X is going towards positive infinity this way. The values of the function are approaching 1/2 from below right here. Remember that the limit represents what's happening on the y-axis. So for that reason, what I would say here is that the value of this limit is 1/2. Why is it this essentially? It's this because you see there's a 2 in this position and a 4 in this position, and 2 divided by 4 is 1/2. One last one that could be interesting. The limit as x approaches positive infinity, say of the following: x³ over x² and then plus 2. What can happen here? The behavior will be a little bit different. Studying it only graphically, take a look. x³ over x² and then plus 2. Notice that in this case, the graph just appears to shoot off towards positive infinity. Even if I scrunch over it this way, and I scrunch it down this way, the pattern still is present, you see? Which is that the function shoots off towards positive infinity. So in this case, speaking only graphically, I would say that the answer to the limit as x approaches positive infinity of x³ over x² plus 2 is infinity. Graphs can be used to study limits and understand the behaviors of various expressions. But that is it for this one, friends. So thank you. I'll see you in the next lesson.